it is positive. It is positive for noble gases. The reason why it is positive for noble gases is because they have. Am I audible clearly, guys? Tell me. आवाज सबको साफ आ रही है?
Yes, sir.
Noble gases, they have 5 positive value of electron gain enthalpy. The reason is they have stable electronic configuration. ठीक है?
So you want to plug in?
My voice is lagging for everyone. Is it lagging for everyone?
No, sir.
It is not lagging. Okay, fine, channel. Sorry. Next, we're going to write the definition of electron gain enthalpy. So, we can see the release when an electron is added to new isolated or is my voice lagging here or is it lagging nothing? Okay, let's see. Okay. Hello. Am I audible, guys?
Yes, sir.
The energy released when an electron is added to neutral isolated gaseous atom to form an ion is known as electron gain enthalpy. Electron gain enthalpy. Okay, that's just the definition. Energy released. Now you write factors affecting electron gain enthalpy. Factors affecting electron gain enthalpy. ठीक है? यहाँ पर समझिए इलेक्ट्रॉन गेन एंथैल्पी क्या बताता है? इलेक्ट्रॉन गेन एंथैल्पी की जो वैल्यू है ना, इट विल बी नेगेटिव. यू विल राइट वेदर इट इज हाईली नेगेटिव, ठीक है, और इट इज लेस नेगेटिव. जब भी हम हाई के बारे में बात करें तो आप समझिएगा, इफ आई से जनरली ना हाई, इलेक्ट्रॉन गेन एंथैल्पी इज हाई, तो आप समझिएगा आई एम टॉकिंग अबाउट हाईली नेगेटिव. सही है? यस और नो? -8 and -2. If I talk about what is the, like in general अगर हम बात करते हैं ना कि कौन सी वैल्यू ग्रेटर है, which is greater guys, tell me, which is greater, -8 या -2? Which is larger?
-2.
-2, right? -2 is larger. लेकिन हम जब बात करेंगे ना इलेक्ट्रॉन की एंथैल्पी की, then will be when I will say that it is high. तो हाई का मतलब क्या समझिएगा? हाईली नेगेटिव. When I say it is higher than that, तो higher than highly negative कौन है? -8 is highly negative. That makes sense? Yes or no? Please tell me, guys. highly negative is -8. That makes sense? बताएं? Yes, ठीक है, चलिए देखिए. Factors affecting electron gain enthalpy. इसमें सबसे पहले first point we will write delta Heg electron gain enthalpy gives an idea about how easily an electron can be added to an atom. To an atom. मतलब, if the electron gain enthalpy is high, highly negative, that means the electron will be added very easily. If the electron gain enthalpy is less negative, that means electron will be added, but with not that much ease. ना आसानी उतनी नहीं होगी, आसानी ज्यादा, आसानी कम. आसानी कम का मतलब मुश्किल नहीं, आसानी ज्यादा या आसानी कम, है ना? That's what delta Heg tells about. If delta Heg is highly negative, then addition of electron is very easy. Just give me a second. Okay. If delta Heg is highly negative, then addition of electron is very easy. If delta Heg is less negative, then addition of electron is less easy. Okay. Now, what are the factors that is going to affect it? Now, when we started to talk about the electron gain enthalpy, it's very important. When I started to talk about electron gain enthalpy, we understood why electron gain enthalpy is releasing energy. Because the attraction increases, number of attraction. अगर याद हो आपको 11 के लिए 11 था, but when we added an electron, now we had 12 attractions. So if the attraction is higher, electron gain enthalpy will be highly negative. बस अब हम लोग क्या देखना है, attraction जहां ज्यादा, the electron gain enthalpy will be highly negative. If the attraction is less, electron gain enthalpy will be less. Electron gain enthalpy will be less negative, highly negative, less negative. यहाँ पे सबसे पहला effective nuclear charge. The first factor is effective nuclear charge. Now, if the Z effective increases, increase in Z effective, meaning more attraction for incoming electron. Nuclear charge ज़्यादा होगा, then what's going to happen? The attraction will be more, therefore delta Heg will be more negative. So delta Heg को जो क्या बोलेंगे is high. You can say that delta Heg is the magnitude of delta Heg increases on increase in Z effective. ठीक है, अगला साइड ऑफ एटम. Size of atom. Size of atom में क्या होगा? When the size will increase, जो आपके पास एटम, जो आपके पास इलेक्ट्रॉन पहुंचा है, that will be far away, because far away from the nucleus, and because it is far away from the nucleus, attraction will be less. जितना साइज बढ़ेगा उतना अट्रैक्शन घटेगा. अगर अट्रैक्शन घट रहा है, that means delta Heg will be less negative, will be less negative. Make sense? Size बढ़ेगा तो delta HEG will be less negative. Third point, electronic configuration. Stable electronic configuration will have less negative delta HEG, because if the electronic configuration is already stable, if the electronic configuration is already stable and you are going to input one more electron, then it will not be stable anymore. Okay? If it is half filled and you have added electron, now it is no more half filled. If it is fully filled and you are adding an electron, it will be no more fully filled. And in those cases, it will be less negative, because the tendency to add electron will be less. अब हम लोग factors पढ़ लिया, then we are going to talk about the trends. Raise your hand if you're done. Let me know if you want to understand any one of the points. I hope these are self-explanatory, by the way. Second. Just waiting for Sabiha now. Sabiha, are you done? ठीक है, चलिए. Now we are going to look at the trends for delta HEG. Right? Delta HEG. First point, as we go in left to right in a period अगर जाते हैं, left to right in a period, what happens? There are two things which happen. Z effective increases and size decreases. ऐसे ही होता है ना? Left to right in the period, because electrons are added in the same shell. When the electrons are added in the same shell, then what's going to happen? Electron negative charge increases, positive charge increases, attraction increases, and because the attraction increases, the size decreases. So now Z effective increase कर रहा, size decrease कर रहा, therefore अब देखिए, Z effective increase कर रहा है, delta HEG will be more negative. Size increase करने पे delta HEG less negative. Size decrease करने पे delta HEG more negative. So both of these factors are going to, what it will do? It will get the delta HEG more negative. क्या लिखेंगे? Left to right in a period, Z effective increases, size decreases. Therefore, delta HEG becomes more negative becomes more negative as we move from left to right in a period. Left to right in a period. सबको समझ में आया ना? Yes or no, please tell me. जो बेटा जसमीन सबिहा चाइमा ज़ैनब, yes or no, please tell me guys. आया सबको?
Yes, sir.
ठीक है. Second point. Second point. On moving top to bottom. On moving top to bottom in a group. Top to bottom in a group. Delta H EG becomes less negative as the size increases. Whenever we move top to bottom in a group, हमेशा क्या होगा? Size increase करेगा. Z effective is always odd. It is constant in those things, right? उन चीजों में क्या रहता है? Constant रहता है. If I move from top to bottom in a group, understood? सिर्फ size बढ़ रहा है. Size बढ़ रहा है तो it will become more. Sorry, it will become less negative. Raise your hand if you're done. Now, if I look at the periodic table, first of all, we have the S block, then we have the B block, then we have the P block. Okay. Now we know that P block में सिर्फ आप noble gases को हटा दीजिए. ठीक है. Remove these noble gases, right? Because noble gases have very stable electronic configuration. इनका delta H Eg तो क्या होता है? This is positive. Okay, if you're going to input an electron, it will go to the new shell that will need energy, and also stable electronic configuration will be disturbed. That will also require energy. Fine. Now, but as we move left to right, अगर आप left to right जा रहे हैं, if you are moving left to right, then what's happening? Delta H Eg is more negative. तो सबसे ज्यादा negative कहाँ पे होगा? This is group 18. This group 17 will be the most negative. And what is group 17? Halogens. So we can write halogens have the most negative electron gain enthalpy in their respective period. In their respective period. मान लीजिए अगर फ्लोरीन की बात करें तो इन द सेकेंड पीरियड फ्लोरीन सबसे ज्यादा, उसके बाद थर्ड पीरियड में क्लोरीन, देन ब्रोमीन, देन आयोडीन, है ना, एंड सो ऑन. Now we are going to compare the delta Heg electron gain enthalpy of fluorine versus chlorine. ठीक है. इस एक पॉइंट को बस लिखते हैं. Fluorine versus fluorine. See you. If I talk about fluorine, then fluorine has electronic configuration 1s2, 2s2, 2p, fine. Okay. And if I talk about F negative, then F negative will have 1s2, 2s2, 2p, 6. Now in fluorine, what is happening? Electron. चल एक काम करते हैं. Fluorine का भी देख ले तो उसके बाद then we can compare. Fluorine will be 1s2, 2s2, 2p, 6, 3s2, 3p, 5. If you add one electron, fluorine negative will be 1s2, 2s2, 2p6, 3s2, 3p6. In fluorine, the incoming electron enters 2p subshell, which is smaller, in size. 2p काफी छोटा होता है ना, which is smaller in size. ठीक है. Therefore, what will happen? अच्छा, therefore क्या है? Leading to कर लीजिए, leading to electronic repulsion, and hence less energy is released. इतना कॉपी किया जरा. Raise your hand if you're done till here. Okay, next. दूसरा ये, in chlorine, the electron enters, by incoming electron है ना, the electron enters 3p subshell, which is larger in size, leading to less electronic repulsion. ठीक है. Which is now 3p is larger in size, so obviously electron will be far away, and that is why there will be less repulsion. And when there is less repulsion, अगर repulsion less होगा, then more energy will be released, and hence more energy is released. So because of this, like छोटा सा reason अगर हम कहें, due to small size of fluorine, delta Heg is of fluorine is more negative than that of fluorine. So expected क्या था? If I go top to bottom in a group, then what should happen? Then the electron gain enthalpy should be more negative. तो हमारे पास expected ये था, delta Heg की बात करें हम, तो फ्लोरीन का ज्यादा होना चाहिए, should be more negative है ना. When I say more, it is more negative than fluorine. याद रखिएगा, more हम बोल रहे, that means it is more negative. This was expected, but what is actual? Actual है delta Heg of fluorine is less negative than fluorine. And what is the reason? Reason is small size of fluorine. या फिर larger size of fluorine भी आप लिख सकते. Raise your hand once you're done. Just waiting for Jasleen now. Okay, everyone's done. Check. Similar is the case for oxygen and sulfur also. Like if I compare the electron gain enthalpy of sulfur versus oxygen, then the same thing happens. Okay. So right next, delta Heg of oxygen versus sulfur. Okay. So oxygen versus sulfur में आप ये चीज देखिए. In oxygen, electron is added in 2p, okay, which is small. Sulfur में electron is added in 3p, which is large. Therefore, delta Heg of oxygen is less negative than sulfur. ठीक है, सेम चीज है, बिल्कुल फ्लोरीन और क्लोरीन वाला हाल है. ऑक्सीजन इज स्मॉलर इन साइज, इलेक्ट्रॉनिक रिपल्शन ज्यादा हो जाता है, एंड सल्फर इज लार्जर इन साइज, दैट्स व्हाई इलेक्ट्रॉनिक रिपल्शन इज लेस, तो एनर्जी ज्यादा रिलीज करेगी. Reset hand also done. Just waiting for Zainab. Now we can write one more point. Second, sulfur will release more energy. Correct. Sulfur will release more energy than oxygen. Right next, electronegativity. Second electron gain enthalpy. Second electron gain enthalpy of any element is endothermic. Is endothermic. Matlab, if you have a neutral atom A and you added an electron, this will give you A negative. But if you add one more electron, then what will happen? The incoming electron will be repelled by the anion. And whenever there will be repulsion, you will have to add some energy in order to make the incoming electron enter the anion. Anion has negative charge, the electron has negative charge, that will repel each other, right? And because they are repelling each other, that particular process will be endothermic. It will require certain energy to go to A2 negative. That means if I want to talk about the successive electron gain enthalpy, like A2 negative, A3 negative, A4 negative, then what's going to happen? It will be more and more endothermic. So successive electron gain enthalpy is always endothermic. As the second electron gain enthalpy is also endothermic. So we can write successive electron gain enthalpy, EGE. Electron gain enthalpy is always endothermic. Is always endothermic. Raise your hand once you're done. Now we are going to write the next one, that is electronegativity. Electronegativity. What is electronegativity? Please write with me. The tendency of an atom to pull electron in a bond. Electron in a bond is called electronegativity. It's called electronegativity. Okay. Obviously, electronegativity means how the atom is pulling electron. Atom will pull electron if from and what? From the nucleus only. Because nucleus has proton. The proton is positive charge. So that positive charge will give the ability, or it will give the tendency for an atom to pull the electron. If that positive charge is high, if that positive charge is high, then what's going to happen? That particular atom can pull electron easily. Or if the size of atom is also small, if the size of atom is small, then what can happen? Then we can say that when we make bond, that bond will be nearer to nucleus. If you are going to have a large atom, then the bonded electrons will be far from nucleus because bonded electrons are always the outermost electron. अगर आपको याद हो, if you have done things in organic chemistry class 10, you must have drawn the Lewis dot structure of carbon CH4. When we talk about CH4, then we used to talk about the outermost electron, the char electron in the second shell, because configuration of carbon is what 2, 4. The bond formation was because of only those 4 electrons. If the atom is small, then those bonded electrons will be nearer to nucleus. If the atom is large, the bonded electrons will be further away from the nucleus. And because they are further away from the nucleus, then what's going to happen? The nucleus cannot pull them easily. जितना दूर होगा, उतनी मुश्किल होगी pull करने में. If the atom is small, we can pull it easily. So we can very shortly write in a period left to right, electronegativity will increase as Z effective increases and size decreases. We can also write in a group, if I go from top to bottom, then the electronegativity is, it is shown by like this. This is known as pi. Mole fraction का जो pi होता है ना, उसका upper case है pi. Pi decreases as size increases. I'm going to give you an electronegativity series, mixing both period and group. सबसे ज़्यादा होता है फ्लोरीन का. Then we have oxygen, then nitrogen, then chlorine, then bromine, then iodine, then sulfur, then carbon, then phosphorus, then hydrogen. How will you remember this? You can remember this as phone. You can remember this as call. You can remember this as bro. Ishq. You can remember this as pyar. You can remember this as hai. क्या बोलेंगे? फोन कॉल ब्रो इश्क प्यार. फोन कॉल ब्रो इश्क प्यार. फोन कॉल ब्रो इश्क प्यार. रिपीट दिस 10 times आराम से हो जाएगा. इश्क प्यार. फोन कॉल ब्रो इश्क प्यार. Copy this down. Raise your hand once you're done. Waiting for Shaima, Jupiter, Justine, and Zainab. write a conclusion of everything. ठीक है, तो हम एक साइड क्या लिखेंगे? In this side I will write in a period left to right. ठीक है, आई एम राइटिंग सेकंड पार्ट दिस साइड, आप लेफ्ट टू राइट उसके नीचे लिखिएगा, ठीक है ना? हम साथ में लिख देंगे, आप नीचे लिखिएगा, ठीक है? पहले देख लीजिए, उसके बाद लिखने चालू कीजिएगा। इन अ ग्रुप टॉप टू बॉटम, ध्यान से देखिए। First of all, we are going to talk about the effective nuclear charge. Obviously, effective nuclear charge in like left to right in a period, it increases. And sorry, not two, not the one. Z effective in a group, it is what? It is constant. Because size also increases and the atomic number or the proton number also increases. The combination of the effect is that Z effective is constant. Second, we have to talk about atomic size. Atomic size decreases. In this case, atomic size सीधा लिख दिया मैं यहाँ पे, आप लोग लिखिएगा पूरा, लेकिन एटॉमिक साइज डिक्रीजेस है ना, बिकॉज यू आर गोइंग टू नॉट राइट लेफ्ट और राइट में से कॉलम बना के नहीं लिखेगा आप, है ना, ऊपर नीचे लिखेगा। देन यू प्लीज राइट एटॉमिक साइज, व्हाट विल हैपन, इट विल इंक्रीज। थर्ड थिंग इज आयोनाइजेशन एंथैल्पी। आयोनाइजेशन, अच्छा और शॉर्ट करके ले रहे हैं उसको, डेल्टा एच ionization. In left to right in a period, what happens? The ionization enthalpy increases because size increase. Sorry, Z effective increase कर रहा है, size decrease कर रहा है, तो removal of electron will be difficult. In the second case, the size is increasing, so removal of electron will be easier. So ionization enthalpy will be lower. Ionization enthalpy will be lower. Fourth is metallic character. Now, metallic character, it is proportional, like it is dependent on what? Metallic character is dependent on ionization enthalpy. If it is easier to remove electron, if it is easier to remove electron, if it is easier to remove electron, then the metallic character is high. But left to right in a period, ionization enthalpy is getting more and more. That means it is difficult to remove electron left to right in a period. So metallic character will decrease. Here also we can, what we can write? When the ionization enthalpy is decreasing, that means it is easier to remove the electron. That is why metallic character will increase. Fifth point, negative electron gain enthalpy. Negative electron gain enthalpy. Now, negative electron gain enthalpy, what happens in left right in a period? We have just seen that it increases because Z effective increases, size decreases. And if I go from top to bottom in a group, then because size increases, the incoming electron will face less attraction. Less attraction matlab electron gain enthalpy will be lower. Lower matlab less negative. High matlab more negative. Now, negative electron gain enthalpy, that is going to tell us about the non-metallic character. Okay. The sixth is non-metallic character. Now, non-metallic character, what will happen? It will increase because if an electron, if the negative electron gain enthalpy is higher, non-metallic character will also be higher. What is non-metallic character? How easily you can give me electron. If you can easily give me electron, I am a good non-metal. If there is an element which is easily eating electron, which is easily taking the electron, that is a good non-metal. And electron gain enthalpy jitna zyada negative hoga, that will tell us that it is easily taking electron. So if non-metallic character is high, that means the negative electron gain enthalpy is high, that means non-metallic character is high. 1, 2 together, 3, 4, 5. 6 will be non-metallic character will decrease because what happens? Negative electron gain enthalpy is increasing. Seventh one is electronegativity. Electronegativity, it increases, and we have seen that it decreases down the road. So you copy this down, raise your hand once you're done. Sorry, everyone's done. So the properties of the periodic property are over, but chapter is not over. There are certain questions that you have to still learn. जैसे एक जो है that is very easy part. It is the prediction of stable binary compounds that would be formed. क्या मतलब stable binary compound? ध्यान दीजिएगा जरा. For example, सवाल से इसको डील कर लेते हैं, ठीक है ना? The properties are done. सवाल से इसको डील कर लेते हैं. See it. You write here, predict the formula of these following pair of elements. Pair of elements. जैसे आपको बताइए नंबर 1, आप उसको ट्राई कीजिएगा, ठीक है ना? If I have to make a compound with lithium and oxygen, what will be the formula for compound? Any idea? Lithium and oxygen. What will be the formula for compound? No idea. Oxygen. ठीक है. थोड़ा ना, you guys can you please turn your mic, on. There are a few things that we will read about lithium. ठीक है ना? Lithium के बारे में बताइए. What is the group number? Group number of lithium. Group number of lithium. I have asked you guys to remember the group number 1, 2, 13, 14, 15, 16, 17, and 18. S block and P block elements. What is the group number of lithium? 1. Very good. Whatever the group number is, that will be the valence electron. Valence electron भी कितना होगा? उतना ही होगा. Valence electron is equal to 1. Then we will talk about a new concept that is known as valency. Valency. ठीक है. In order to understand what is valency, please don't write. ध्यान से सुन लीजिए. बार-बार आपको रिपीट करना होगा वरना. ठीक है, ध्यान से सुन लीजिए. I hope all of you have removed, like, you have dropped your pens. Please drop your pens and listen to me very carefully. 1, it is closer to 0 or 8. 1 is closer to 0 or 8. Tell me, guys. 1 is closer to 0 or 8. 0. How much closer? How much closer?
1.
1. That is the valency. ठीक है, ध्यान सुनिए. Oxygen, what is the group number? What is the group number?
16.
16. Take the unit digit. Take the unit digit. ठीक है, group number is 16. Valence electron is the unit digit. Unit digit क्या है 16 का? 6.
6.
ठीक है. Valency. In order to understand what is valency, 0 or 8. Tell me what is closer, 0 or 8?
8.
8. How much closer? How much closer?
2.
2. But that is valency. See, I'm just asking you the questions, right? How much closer? First of all, 0 or 8. Then how much closer? That will give you the valency. आपकी जबान से ऐसे ऑटोमेटिक निकल जाएगा. 6 and 8. How much close they are? 2 है. दोनों के बीच में डिस्टेंस कितना है? What is the distance between 6 and 8? It is 2. Now अब आराम से कर लीजिएगा. Lithium, oxygen. Valency of lithium is 1. Valency of oxygen is 2. Lithium will get 2. Oxygen will get 1. Chris and cross. Li2O. Does this make sense? Yes or no? Please tell me, guys.
Yes.
Yes, sir.
चलिए कॉपी कीजिए प्लीज. कर लेंगे ना? You need to remember the group number only. और कुछ नहीं चाहिए आपको. From group number you will get the valence electron. From valence electron you can get the valency. What will you ask? 0 or 8? Then what you will ask? How much closer? You will ask what is closer? 0 or 8? Then you will ask how much closer? Waiting for Jasleen, Shaima, and Zainab. ठीक है everyone is done. चलिए सिमिलरली करते हैं हम सेकंड नंबर मैग्नीशियम एंड नाइट्रोजन। ठीक है, मैग्नीशियम का ग्रुप नंबर बताइए। व्हाट इज द ग्रुप नंबर?
2.
2. valency will be group number 2, valence electron 2 है ना, valency will be
2.
valency will be 2 only। ठीक है, चलिए नाइट्रोजन के लिए बताइए। व्हाट इज द ग्रुप नंबर फॉर नाइट्रोजन? ग्रुप नंबर फॉर नाइट्रोजन
15.
15। वेरी गुड।
15.
15 यूनिट digit 5
5.
है ना। 5 is closer to 0 or 8, which is closer to 8? 5 0 or 8, which is closer?
8.
8. How much closer? How much closer?
3. 3.
3। very good। so Mg3n2, this is magnesium nitride by the way, magnesium nitride। आप लोगों ने ये सब नहीं पढ़ा है पहले? जस्टीन, शाइमा, जैनब, सबिहा, जोगिता, टेल मी गाइस, you have not learned these things?
Sir, we have studied in 9th.
You have studied in what, Shaima?
In 9th grade.
9th में। अच्छा 11th में नहीं पढ़ाया गया फिर से? दिस इज देयर बाय द वे है ना। एंड अब देखिए जरा यहाँ पे, ठीक है, व्हाट इज द एक्चुअल प्रोसेस क्या है? एक्चुअली यू नीड टू नो द वैलेंसी। ठीक है, वैलेंसी को पता करने के लिए वैलेंस इलेक्ट्रॉन, एंड बिकॉज वैलेंस इलेक्ट्रॉन कैन बी नोन बाय द ग्रुप नंबर, वी फॉलो द ग्रुप नंबर राइट। ग्रुप नंबर अगर है हमारे पास तो उसी को फॉलो कर लेते हैं, फाइन, ग्रुप नंबर से। नाउ लेट अस सपोज you have been given element 71, element 71 and fluorine। या तो you try to find out what is the group number of element 71, ठीक है, तो you try to find out that, fine। Otherwise what we can do, you can write the electronic configuration and then you can do, for example, element 71, ठीक है, atomic number क्या है इसका? atomic number is 71। so 71 से पहले कौन आता है? you have xenon। xenon has electronic configuration of 54, sorry, atomic number 54। how much is remaining? 71 minus 54 will be equal to how much? 11 11 और 6 11 से 11 से 11 से 17 17, right? 17 electrons are remaining, तो हम यहाँ 17 electron कहीं पर इतना हमको करना है, we have to add 17 electrons, right? now xenon is fifth noble gas। fifth noble gas है तो 6 से स्टार्ट करेंगे। 6 is 2, 4 है 14, 5 3 1। ऐसा कुछ होगा ना कॉन्फ़िगरेशन? टेल मी गाइस। 6 is 2, 4 है 14, 5 D 1, क्या ख्याल है? इसके बाद आता 6 आता, बट 5D भरता तब तो 6 आता, फाइन। नाउ व्हाट द आउटर मोस्ट शेल? दिस इज सिक्स्थ शेल, फोर्थ शेल, फिफ्थ शेल। आउटर मोस्ट शेल कौन सा है? 6 वाला। हाउ मेनी इलेक्ट्रॉन्स इन द आउटर मोस्ट शेल? 2 इलेक्ट्रॉन्स। नाउ 2 इज क्लोजर टू 0 और 8, बैलेंस इलेक्ट्रॉन ये हो गया, तो 2 इज क्लोजर टू 0, हाउ मच क्लोजर? 2। तो जो एलिमेंट 71 है उसके लिए वी आर राइट 2, लेट सपोज दैट इज दिस इज x। फॉर फ्लोरीन तो वी ऑलरेडी नो, फ्लोरीन के लिए आपके पास दी valency will be 1 because एक इलेक्ट्रॉन डालेगा तो आई होप यू कैन अंडरस्टैंड। ऐसा होता है ना 2,7 नहीं 2, क्या होता है 2, नहीं 2,7 है, 2,7, हाँ नहीं, ठीक है 2,7, ठीक है। तो 7 is the valence electron, 8 or 0, it is closer to 8, how much closer? 1 closer है ना, तो valency 1। so the formula will be what? x1 f2, xf2 will be the formula। ठीक है, आउटर मोस्ट शेल लेके आपको क्या कर लेना है? देन यू विल कैलकुलेट द वैलेंसी। आउटर मोस्ट शेल हैज 2 इलेक्ट्रॉन, वैलेंस इलेक्ट्रॉन इज 2, 2 is closer to 0 or 8, it is closer to 2, it is closer to 0, how much closer? 2 closer। so कर लीजिए प्लीज, what is this? Just waiting for Jasleen. Good. ठीक है, next. This was one of the topic जो सिर्फ सवाल के फॉर्मेट में रहेगा. Another topic that we have is diagonal relationship. Diagonal relationship. Elements like lithium and beryllium. So similarity with second element of next group. That is with magnesium and aluminium. Magnesium and aluminium. This similarity is known as diagonal relationship. Diagonal relationship. ठीक है. ठीक है, लिथियम के नीचे होता है सोडियम. आफ्टर लिथियम ये है बेरिलियम. बेरिलियम के नीचे होता है मैग्नीशियम. Now I will leave the D block as I have said earlier. Also, D block is not very important for you guys right now. ठीक है, D block. If you move to the direct D block, they will have boron. है ना, बेरिलियम के बाद कौन होता है? बोरॉन. बोरॉन के नीचे एल्यूमिनियम. So lithium, it has similar, it shows similar properties to that of magnesium. और उसी तरह से बेरिलियम जो है, it shows similar properties to that of aluminium. आपको दिख रहा होगा डायगोनल बन रहा है. क्या होता है डायगोनल रिलेशनशिप. ठीक है. As you can see, you are forming a diagonal type of thing ना. So this is known as diagonal relationship. अब ये diagonal relationship exist क्यों करता है और कहाँ कहाँ मतलब किन किन चीजों पे एग्जिबिट करता है. ठीक है. तो फर्स्ट ऑफ ऑल रीजन लिखते हैं यहाँ पे कि क्यों होता है. किन में होता है? लिथियम मैग्नीशियम बेरिलियम एल्यूमिनियम, है ना, ये लिखिएगा. फर्स्ट ऑफ ऑल व्हाट इज डायगोनल रिलेशनशिप, ये सवाल पूछा जा सकता है इन योर स्कूल एग्जामिनेशन. Another question can be asked, which of the following shows diagonal relationship. Then you have to remember lithium, magnesium, beryllium, and aluminium. They show diagonal relationship. Why do they show diagonal relationship? Diagonal relationship exists due to identical size of ions. ठीक है, of ions. ध्यान से देखिए. If I move from lithium to beryllium, the size will increase. But if I move from beryllium, size will decrease, no? Because left to right in the period, size decrease. My bad. Size will decrease. If I move from beryllium to magnesium, then the size will increase. तो ध्यान से सुनिए. अगर हम बेरिलियम पे अगर मान लीजिए बेरिलियम से लिथियम, what will happen? Size will increase. लिथियम से बेरिलियम size decreases. बेरिलियम to lithium size will increase. बेरिलियम से मैग्नीशियम भी क्या हो रहा है? Size is increasing. That is why lithium and magnesium, they will have similar sizes. Because of this similar size, as you know that all the properties, main properties, electronic enthalpy, ionization enthalpy, electronegativity, all of these properties are dependent on Z effective as well as what? As well as size. So because the sizes are similar, then what's going to happen? If the sizes are similar, then the properties of these elements are also going to be similar. यही reason है. Diagonal exists due to identical size of ions. ठीक है, इसमें लिख लीजिए as we move. एक और पढ़ लीजिए like size सेम कैसे हो रहा है as we move. As we move क्या लिखना है? right side leftwards. As we move leftwards, ठीक है, बेरिलियम से लिथियम size increases, and also size increases as we move down. Beryllium से lithium भी size increase, beryllium से magnesium भी size increase, therefore size is going to be similar. Size similar, तो properties be similar. Next point. Now, where do they show similar properties? Similar property. Similar property. Density. Electronegativity. And polarizing power. And polarizing power. इन सब में क्या होता है? इन सब में देयर विल बी सिमिलर प्रॉपर्टी. देयर आर अदर्स आल्सो. आप एक्सेप्ट कर दीजिए. तो Zainab, can you please turn your mic on? Zainab, can you please turn your mic on?
Yes.
जैसे आपके पास मान लेते हैं ना, you have lithium, beryllium and magnesium. Fine. So we are at beryllium. If I move beryllium to lithium, अच्छा मान लेते हैं beryllium का size है 10. So when I go from beryllium to lithium, what will happen? Size will increase or decrease?
Increase.
No idea. Increase ना, because आप अगर ऐसे जाते हैं तो साइज डिक्रीज करता है, तो उल्टा जाएंगे तो साइज क्या होगा? इंक्रीज करेगा ना, सेंस.
Yes, sir.
ठीक है. अच्छा, तो मान लेते हैं 12. बेरिलियम से मैग्नीशियम, व्हाट विल हैपन इफ आई गो डाउन द ग्रुप? देन द साइज
Decreases.
देखो, देख के बताइए ना, ऐसे मत बताइए. अभी तो सारा कुछ लिखा है ना, साइज वाइज के बारे में सब कुछ तो लिखा है हम लोगों ने. लुक एट द कंक्लूडिंग पॉइंट एंड टेल मी इफ आई गो डाउन द ग्रुप देन द साइज
Decreases.
डिक्रीजेस.
Or is it increases?
अरे यार, मतलब इसमें तो ये तो याद हो जाना चाहिए. लेफ्ट टू राइट इंक्रीज करेगा, सॉरी, लेफ्ट टू राइट डिक्रीज करेगा, बिकॉज मतलब आपके पास ज्यादा प्रोटॉन है तो ज्यादा अट्रैक्ट करेगा. बट इफ यू गो डाउन द ग्रुप, तो मोर एंड वन ऑर्बिट, टू ऑर्बिट, थ्री ऑर्बिट, फोर ऑर्बिट, तो द ऑर्बिट्स आर इंक्रीजिंग, तो साइज इंक्रीज करेगा. साइज इज इंक्रीजिंग. तो मैग्नीशियम का मान लेते 13. कैन यू सी दैट देयर आर सिमिलर साइजेस? 10 से यहाँ पे इंक्रीज किया तो 12, 10 से यहाँ पे 13, तो ऑलमोस्ट सिमिलर. यस और नो?
Yes, sir.
है ना? दैट इज बिकॉज ऑफ दिस सिमिलर साइज ओनली वी आर हैविंग सिमिलर प्रॉपर्टीज. Raise your hand if you're done. Waiting for Jogita and Zainab. Just waiting for Zainab. अगर लिखिएगा anomalous behavior of second period elements. Anomalous behavior of second period elements. पहले लिखा. ठीक है, write these points. धीरे धीरे आपको समझ में आएगा. The first elements, the first elements of groups 1 and 2 and group 13 to 17 differs in many aspects from subsequent elements of the group. Subsequent elements of the group. Okay. That means, for example, in the group one element, अच्छा group one में ना hydrogen को मत रखिए, because hydrogen का जो position है, we have seen in the limitations of the periodic table that is hydrogen का जो position that is not fixed. Hydrogen can be placed in group one as well as in group 17. Because hydrogen अगर एक इलेक्ट्रॉन घुसा तो तभी खुश है. If hydrogen is gaining one electron, if hydrogen is losing one electron, it is behaving as group one. If hydrogen is accepting one electron, it is behaving as the group 17. ठीक है? Because group 17 elements also they gain one electron. So that is why group hydrogen को छोड़ दिया. After hydrogen we have lithium, beryllium, sorry, lithium, beryllium, Linacrab-Cusper, lithium, sodium, potassium, rubidium, cesium, and francium. Right, that is the group one. So first element in the group one is lithium. So what anomalous behavior of second period elements is that lithium की properties are quite different than the other elements. Lithium के बाद कौन है? Lithium के बाद है sodium, potassium, rubidium, cesium, francium. These elements they have very similar properties, but there are certain properties of lithium which are different than the subsequent elements of the group. Okay, that is anomalous behavior. अच्छा, ग्रुप 1 और 2 में क्या होता है, ध्यान दीजिएगा. The first element of group 1 2, that is lithium and beryllium form compounds with high covalent character. High covalent. अच्छा, इसके बाद एंड है high covalent character due to their small size. ठीक है. अब इसके बारे में हम नेक्स्ट क्लास में पढ़ाएंगे कि बस ये समझिए कि बिकॉज ऑफ स्मॉल साइज दे हैव most of the element, for example N, sodium, potassium, rubidium, cesium, francium, they are going to make ionic compounds. ना NaCl ionic है, KCl ionic है, NaBr is ionic, sodium oxide is ionic है ना, potassium oxide is ionic. ठीक है. All of these are what making ionic compounds. But lithium, it also makes lithium oxide. That lithium oxide has high covalent character than the other oxides, right? So they tend to make compounds with high covalent character. Why? Because of their small size. Now, how small size is affecting the covalent character, वो हम बताएंगे next class. कल बताएंगे, ठीक है? उसके बाद देखिएगा. Another thing why they are different is the second period elements only has 4 valence, 4 कौन से. ठीक है. सेकंड पीरियड यानी कि आप सेकंड ऑर्बिट में, सेकंड पीरियड मतलब यू आर इन सेकंड ऑर्बिट. इन सेकंड ऑर्बिट यू हैव 2s, इसमें 1 ऑर्बिटल एंड 2p, इसमें 3 ऑर्बिटल. The total number of orbitals that you are having for second period element is only what? It is only total number of orbitals कितने हैं? 4 ही हैं. Therefore, they can accommodate only 8 electrons. 4 ऑर्बिटल है तो 8 इलेक्ट्रॉन रख सकते हैं in their valence shell. In their valence shell. But if I talk about the subsequent element, अगर हम थर्ड पीरियड की बात कर लें, ठीक है, थर्ड पीरियड की बात करें, तो थर्ड पीरियड में प्लीज रिमेंबर यू हैव 3s, 3p and there is also one is that's called 3d. 3s, 3p, 3d. That is why what happens, it becomes 18 electron. Third period elements can hold up to how many electrons? Up to 18 electrons. That is also there are some properties which are different. Now अगर 4 की बात करें तो उससे ज्यादा ही होगा. But the सेकंड जो है ना वो 8 ही कर सकता है. द रेस्ट ऑफ देम दे कैन हैव मोर देन 8 इलेक्ट्रॉन्स एंड दैट वे दे कैन मेक मोर देन 4 बॉन्ड्स आल्सो. नेक्स्ट पॉइंट लिखिएगा. बट नेक्स्ट पॉइंट इसी है. बट बियॉन्ड सेकंड पीरियड, beyond second period, elements have tendency to make more than 4. It has a tendency to have more than 8 electrons and hence make more than 4 bonds. लिखिएगा the second period element exhibit greater tendency to form 5 bonds. 5 bond कैसा? p5 p5. p5 p5 क्या होता है? जब पाई बॉन्ड सिग्मा बॉन्ड तो आप लोगों को कुछ पता ही नहीं है अभी. ठीक है ना. पाई बॉन्ड सिग्मा बॉन्ड हम याद करा देंगे आप लोगों को. ना यू राइट दिस पॉइंट इन दिस पर्टिकुलर चैप्टर. एक्सप्लेनेशन डिटेल वाला जो है वो कब आएगा? एक्सप्लेनेशन जो डिटेल वाला आएगा केमिकल बॉन्डिंग वाले चैप्टर है ना. बिकॉज अभी तो आपको क्या होता है सिग्मा बॉन्ड पाई बॉन्ड अभी नहीं पता है. राइट. डोंट वरी. अगर पता है तभी कोई बात नहीं, पता नहीं है तभी डिटेल में हम कब जाएंगे? इन डिटेल वी आर गोइंग टू गो इन द केमिकल बॉन्डिंग. जैसे हम व्हेन आई विल टॉक अबाउट द फॉर्मेशन ऑफ पाई बॉन्ड उसी टाइम हम चले जाएंगे कि 2p मतलब p5 क्या होता है ड्यू टू देयर स्मॉल साइज. ड्यू टू देयर स्मॉल साइज. Reasons. The reason क्या है इसके? Like why are the first elements of each group different than the other? Very small size. है ना. और obviously we are comparing it with the subsequent element ना तो काफी छोटा होता है. आप समझिए कि सेकंड जो पीरियड एलिमेंट्स होते हैं ना, सेकंड पीरियड एलिमेंट्स और द फर्स्ट एलिमेंट ऑफ ईच ग्रुप, उसके अंदर सेकंड शेल होता है. सेकंड शेल में हाउ मेनी इलेक्ट्रॉन? ओनली 8. अब 8 इलेक्ट्रॉन दो शेल में. और इफ यू गो टू द थर्ड शेल में कितने? 18. मोर देन डबल. 8 का डबल 16 होता है. 16 से भी ज्यादा होगा. दैट मींस third shell is very large as compared to the second shell. As compared to the second shell, third shell is very large. ठीक है. very small size. High electronegativity.